In my last video, I showed that I could get a C program compiled and running on my 286 computer. And again, very basic C program. Since then, I've done some cleanup and I've found some issues with the code that I had, and so I've cleaned up some little things. And I've also added support to run C++ programs. And I am doing some writing to my video directly from the C++. So I thought I would walk through that in this video and just kind of show you how I'm building this up a little bit. I'm going to start out with some source code, and I'm going to very quickly run through some code here. Starting out with, I have this hello.c. This is the version essentially that I used last time. I'm using standard IO, and I do a printf, and I send out a string. And so I've updated this for today to say 323. And then this C is just representing that this is coming from the C code. I've also then created a C++, and that one does something similar. And this one does a C out using IO stream. And I'm basically sending out the string, same string other than I say CPP, so that if I ever see it in the output or inside of a ROM BIOS file, I know this came from the C++ code. Something else you're going to notice in here, though, I am using a procedure called draw rectangle filled. I can send it XY start, XY end, and a color, and if I look at it, it then calls draw pixel. And draw pixel is going to make an interrupt call, and I'm using this i86.h, which is available. I'm using this Open Watcom assembler, and it has an i86.h that allows me to make direct interrupt calls to my system. And in this case, I'm going to use interrupt 10, which is a BIOS interrupt call, and that is for video services. And I'm going to use a procedure or function within that of 0C, which is a draw pixel. So I want to draw a pixel specifying a color. I then append that color into that. So my A register is saying that I want to do a 0C with whatever color got passed into this procedure. The C register is going to hold my X position, D register holds my Y position, and I raise the interrupt. And down here, you're going to see I have a quick little loop, and all that loop does is draw a series of rectangles, small rectangles starting at 200 for my X, 200 for my Y, and then it draws over to 204 and down to 204, then it offsets everything by 10 to the right and does it again, and it does that 5 times. So I'll get a series of boxes with some slightly varying color. I'm just modifying the color for each box here. So simple C++ program. I'm going to write a string, and I want to write some or draw some colored boxes. Simple call to say draw a rectangle. The rectangle says draw pixels, and then the pixel actually does the interrupt calls over to my system and raises interrupt 10. So that's my hello CPP, and then my hello C. Those, when I build them, basically get put into the main flash BIOS that I have, and I'm going to load those on the fly. And this loading on the fly looks something like this. So basically, I have a procedure that lets me copy from ROM into RAM one of these COM files, either the C version or the C++ version. Just simply grabs different source locations in my ROM memory, but it copies it to the same runtime location in RAM. So if I run the C version, it copies over to that location, and then it basically runs it, and it's going to set my registers. In the last video, I didn't have these set correctly, so I've cleaned this up a little bit, and then I'm going to go ahead and jump to that program and let it run. And when that program is done, there will be an interrupt that it calls, which is down here. There's a terminate process, and now I've put in code to take control back from that process that was running and put it back into my main operating system. So I can now run a program, run it again, and I don't have to reboot. In the last video, I was halting at the end of that, but now I'm actually transferring control back. So let me maybe just show this running a little bit. Here is my debug output, and I am recording my screen also. So let me on my screen just pull that up so I can see it. I'm going to go ahead and power on my system. And my system comes up, and you can see that it does some just debug logging that I just use to read from some serial EEPROMs and from my SD card just to make sure things are working when I turn on. You can see my video output there. It shows, I've not updated the version information, but I'm sitting at a prompt now. I did update my help so that when I type help, it adds in and shows me which function keys I can press to do different things. But here I can run either run DOS-COM-C or run DOS-COM-CPP. And run DOS-COM-C will load and run the C version of what I was showing for code. So I'll say run DOS-COM-C. And there it says, hello world, the C version 323 to the screen. And you can see in my debug window what it went through, because I'm logging every interrupt 21 call to my debug window. So it did a set block, basically asking for memory or requesting a certain amount of memory. It's then asking for a DOS version. It's asking for a lead byte table, which it sounds like for US DOS, that is always ignored. Set block, it's changing its mind. It wants more memory is what that's showing. And where I'm getting that is, here are all my registers, A, B, C, D registers, and then CS, DS, and ES. But first it asked for 2B5 for the amount of memory, and now it's asking for 4B5. So it's increasing how much memory it's asking from the operating system. Then it's doing an IO control call. It's asking about basically my console output, this file handle 1 that I'm using. And then it writes to it, and it's asking to write 15 characters starting at this address. And this is all dynamic. I'm actually then going to that address. I'm not manually pointing to anything like I was in the last video. So I go to that address, and then I write out those characters to the debug window and up to my screen. And then it calls a terminate process. And at that point, I pass control back to the operating system. So now I can come back to the operating system and, run another command, like I want to see my version, or I can now go and run that other program. So I'm going to say run DOS-COM-CPP. Now this version also writes out a string, and it drew out these little squares or rectangles, rectangles in this case that are squares, that have a variety of colors. And so you can see that it wrote those out. Now I only write out to one frame on my video card. So like right now, if I hit F12 on my keyboard, I can toggle video frames. And so here's the other frame, and you can see those do not exist on that frame, and I can toggle back. But later now, what I can do is I can add support to write to both frames or animate and have different content on different frames. All I'm trying to show here, though, is that the framework for me to write directly to my video card from CPP or from C++ is working just fine. And if I go back to my code for a minute, what you're going to see here as I get into this is in my video code, I have support for an interrupt service routine for int 10. And when I come into that, I first check if it's the 0A, which is write char, and if it is, then I print out the char. If it's 0C, which is what I'm using to draw these graphics from C++, then it comes in here, and again, my colors being passed in as AL, BH I'm not using for the moment, CX, DX is basically where I want it positioned. I then push that stuff onto a stack and call an existing procedure I had that draws a pixel. So that interrupt 10 is being called over and over and over from my C++ code to actually draw those little squares on the screen. All of that seems to be working pretty well. And as I've been going through this, I found a couple of things. I found a bug in my VGA code that I cleaned up that was causing some issues. That and how I was not setting the segment registers when I loaded a program was causing a little bit of weird output. So on this serial output that you're seeing down here now between my C and the C++ versions, it looked a little bit different in the last video, and that was because of some of those other bugs I had. But at this point, it's pretty clean, I think. And you can compare, in both the C and the C++, I'm writing out to the console here, and how it got done is almost identical, other than the C version, when it gets compiled, it asks for this get lead byte, where that table is. And in the C++ version, it doesn't bother with that. And other than that, it's 4A30, 4A44. And if I come down here, it's this exact same thing that whether I did it in C or C++, I'm getting the same result minus this unnecessary get lead byte table call. So all that's working. My screen output's working. After I did that drawing, I can come back and, do things like type help and keep on working in the operating system. Again, you're seeing that flicker because it's swapping frames back and forth. Right now I'm just pressing my F12 key that lets me toggle manually. But as I was drawing to the screen, I was basically having it draw on one frame. But when I draw characters, I draw on both frames, so it's toggling back and forth fast. That's why you see that flicker, because this doesn't exist on both frames. But that's all stuff I can play around with and do stuff with later. On my system here, if I go back to the C++, my next intention is to add calls to custom interrupts. So I'm raising interrupt 10, but I can raise other interrupt numbers and populate those other interrupts in the interrupt vector table for my 286 code. Or I could use other functions besides the ones I've used so far, like this is function 0c. I could probably find another unused number for a function number and have a version that writes the pixel to both frames, or have a call that swaps my frames so I can write the pixel, swap the frame, write a pixel. So I can really control how I want things to show up on my screen, whether I write to a single frame, both frames, I can toggle frames. I already have procedures in place to draw circles and rectangles and lines. Aren't quite done yet, but drawing shapes in my assembly code for the 286, I could have an interrupt that just calls those routines and not have to do all that pixel by pixel stuff in C++ and just say draw a rectangle, raise the interrupt to draw a rectangle, and pass in the coordinates through the registers A, B, C, D. Right now this all seems to be working. Seems like I've got a framework that I can build on, so I can come in here, I can do C++ coding, I can build it. And once I get an actual storage mechanism working with a file system, these files, of course, would go on the file system, and then I can just load by reading from the file system, copying the COM file into a 64K segment of RAM and jumping to it, and then I can jump back out to my operating system when I'm done with that process, with that whatever that 64K COM file might be. So I think those are the major updates I've got at this point. It seems like this is coming together, and if you've got feedback, suggestions, let me know. Again, I know there's a lot of stuff for me to work on here in my coding, but I'm just happy to see the pieces coming together, and it seems like something I can spend the upcoming months and months and months working on, but good stuff here. And all of this is helping me just kind of understand how this is all working, so that maybe at some point I can get an open source DOS running on this, or an actual Microsoft DOS, get my BIOS to the point where it will support the minimum stuff I need to do that. But for now, I'm just hacking away at my own operating system and BIOS, and now some C++ on top of that.